So what is meant by logarithm basically? For example, I have one program, just imagine I have one program or function that accepts input, and what it will do? It will produce output, right? That is what is called function. So if I say I have function f of x equals to two power 3, what it will do? My input, what it will give me output? What is the output of this? 8, right? 2 multiplied by 2 multiplied by 2. This is output. This is normal scenario. But here in our logarithms, so when you have a power like this, power or exponent or indices like this, we will try to represent in different format. That is called the other way of representation of this exponent. Can be easy representation. One of the easy representation is logarithm. So here our example is 2 power 3. Our example is 2 power 3. Now we will see how can we represent 2 power 3 in logarithms. Before that, what logarithms will tell, this is normal flow. If we give input, the function will give output. But in logarithms, I have output as input to my function or program or what it may be. Logarithms will give you input. What is my input? So in normal way of representation, if I have input, in normal way of representation is if I have input, I will get output. In logarithm way of representation, if I have output, I can tell you what is the input. This is kind of reverse engineering our programming. So sometimes we may need to do reverse engineering to solve the problems. So now we will see how to represent an exponent or indices or power in logarithms. Okay. So for example, as we discussed, we have 2 power 3. 2 power 3 output, what is output? This is output, right? 2 power 3 output is 8. So in logarithms, other way of representation, how can we say log base 2 8, this is my output, equals to, this is my growth rate, this is my output, end of the output. How many times we need to multiply? How many to get output 8, end of the result? How many times I need to grow myself? How many times I need to grow myself as a number 2? How many times? I need to grow myself 3 times, so that I will get 8 as output. Base 2 of 8 equals 3. Log base 2 of 8 equals 3. It is same as this. So now same this thing we translate it into log, but differently. Base with base, and this is output in this case, but here this is output. How many times? See, here the interesting thing is, factor is, this is growth rate. So if you give me some amount of time, and leave me, for every same amount of time I will double. That is what it is saying. It is growth rate. If I given 3 minutes of time, for example, for every minute I am saying I will double myself. I am saying I will double myself. Okay? So to get the output 8, how many minutes I need? I need 3 minutes. This is growth rate. This is how much time you need to become like this. Right? I hope everyone understand that. Just try to understand this. First, we represented 2 power 3 as log of base 2 of 8 equals 3. Now we need to understand this. 2 represents growth rate. If I say as a 2, if I am number 2, I am saying if you give me 1 minute, I will double myself. If you give me 1 minute, I will double myself. What is my expected output here? 8. To become 8, how many times I need to double? I need to double 3 times. That is what this formula, this representation says us. So, for example, if I say 16 here, so what will be the number here? So, as a number 2, what I am saying, on every minute I will double. So, to reach this point 16, how many minutes I need? I need 4 minutes. That means 2 power 2 power 2 power 2. 2s are 2, 2s are 2, 2s are 2. 4, 8 multiplied by 2, 16. I got the 16. So this is the basic idea of logarithm. So one more time I am repeating. Don't write it. So first thing, how can we translate 2 power 3 into log? Log base 2 of output equals to how many times, how much time I require to become like this. I am as a 2, to become like this I need 4 minutes. If I say for every minute I doubles, right? We can, if I have 3 power 4, same way we can represent it as log base 3. What is 3 power 4? 3 we need to multiply by 4 times. 9, 27, 27 multiplied by 3. So the result equals to how many times I am telling? 4. So this result you can define based on this value. Right? How this is growth rate, this is how much time you require to become like this. For example, you are an amoeba. I am just explaining, I am combining both botany and zoology and logarithms. Just imagine you are an amoeba. Or you are a virus, or you are an amoeba like this. Okay, amoeba will have only one cell actually. So this amoeba doesn't have any shape. You can draw any shape you want. So as an amoeba, what I am saying, I have a property. That property makes me every day, after every day I will become 2 amoebas. If I am 1 amoeba now, after 1 day completes I will become 2 amoebas. After second day completes I will become 2 to 4 amoebas. So here I will get 2 amoebas. Here I will get 3 amoebas after 2 days. What I am saying, as an amoeba, I need 1 day of time to become 2. For example, if you ask me to become 8 amoebas, how many days we require? To become 8 amoebas, how many days we require? We need, already we are 4, so each amoeba will become 2, so I need 3 days. That means 2 power 3. That means log, my growth rate is how much? 2. What is my output? 8. To become output as 8, how many times I need to grow? 3 times I need to grow. That means log base 2 8 equals to 3. If you allow me 3 days, if you leave me 3 days as a 2, I will become 8. This is what it is saying. For example, instead of amoeba, if you deposit money in one of the bank, if the bank says on every day I will become 2 rupees. What does that mean? In the same way, to become as 8 amount of money, I need 3 days. If my growth rate is 2, right? So, for example, if it is 9 and if it is 3, if it is 9, my growth rate is 3, and I need every 1 day to become double. So how much I need? Here, how many days I need? 2 days. Because 3 power 2 equals to 9. So this is the basic idea of logarithms. How to represent an exponent, or this thing we will call it as exponent or power or indices. How to represent this kind of number in logarithms in an easy way. So the idea is the growth rate and time and what you are expecting. If you are expecting something out of me, you need to give some time so that I can double myself to reach your goal. That is what logarithms. So this logarithms will be very helpful to solve many real world problems, but we don't cover those things. But our motive is to understand some laws exist in logarithms. So we will learn those laws in logarithms so that you can utilize in while learning the data structures. There is no need to learn also, but if you learn, that will be good. And I hope now you understand the approach of studying data structures, functions, graphs, plan, and logarithms. Now you are clear. Now in next class session, we will discuss about logarithm laws so that you will be more clear on logarithms.